In this video, we're going to continue our discussion with solving quadratic equations. So let's take a look at the first example. Is there a greatest common factor I can take out of all three of these terms other than 1? In this case, I can factor out or divide out a 2. Now, the leading coefficient is still a 1. With 3 terms, I'm going to factor this by grouping. So I need to find factors of 60 whose sum is negative 19. In this case, that's negative 15 and negative 4, because negative 15 times a negative 4 is a positive 60, and when I add those same two numbers up, I get a negative 19. Okay, so let's replace the negative 19y. Okay, so now let's group them. So I can factor out a 3y from the first two terms. And now I can factor out a negative 4 from the last two terms. So factor again. All right, so this is completely factored. So now I want to take every factor that contains a variable and set it equal to 0. So 2 equal to 0 does not make sense, but the other factors contain variables, so I'll set each of those equal to 0. So my two solutions here are 4/3 and 5. You should verify on your own that both of these are actually solutions to this equation. Okay, let's take a look at the next example then. So, again, make a note here. I cannot set each of these factors equal to 5. The only time I can do that is when the equation is set equal to 0. Okay, so I'm going to subtract the 5. Now I'm going to distribute. Okay, is there a greatest common factor I can take out of all these terms other than 1? In this case, that's no. So again, the leading coefficient is not 1, so I'm going to do this by factor by grouping. So I want factors of negative 160 whose sum is 36. In this case, that's a positive 40 and a negative 4. Adding the two numbers together, that gives me 36, but when I multiply those same two numbers, they give me negative 160. Okay, so let's factor. All right, so I'm going to group the first two terms, and I'll group the last two terms. So I can factor out an 8x from the first two terms. Now the last two terms, the only greatest common factor they have is a 1. Notice they're both negative, so I'm going to factor out a negative 1. So factor again. Now I'm going to set each factor that contains a variable equal to 0. So these are my two solutions. And again, you should verify that both of these are actual solutions to this equation. Okay, last example I'm going to do here. So again, first thing I want to do is I want to set this equal to 0. So I'm going to add the 2. And now I'm going to take this binomial and multiply by this binomial. So I'll use the FOIL method. First term's x squared, outer is a positive 2x, inner is negative x, and the last is minus 2. Don't forget the plus 2 is equal to 0. Combine like terms, so we have x squared plus x. Now this is nice. Negative 2 plus 2 is 0. Okay, first question, is there a greatest common factor I can take out of both of these terms other than 1? In this case, I can factor out an x. I cannot factor any further, so I'm going to set each factor that contains a variable equal to 0. This is already solved. So our two solutions here are -1 and 0.